Hello students, and welcome to our lesson on adding, subtracting fractions, as well as mixed numbers. The key thing that we're going to be understanding today is that in order to actually work with fractions in terms of addition and subtraction, we need them to have the same denominator. Otherwise, we don't really know what's going on, quite honestly. So let's see a visual of what I mean by we don't know what's going on. So the denominator of a fraction tells us how big each piece is, because the denominator tells us how many parts the whole is split into. So the denominator of a fraction tells us the size of the pieces. To add or subtract fractions, the pieces must be the same size. So we cannot add 1/2 and 1/3 directly because the pieces are different sizes. So notice on the left of the screen here, we have one piece up here and we have one piece down here, where the top piece is 1/2 of the rectangle and the bottom piece is 1/3 of the rectangle. So they're each one piece, but the pieces are different sizes. We can't actually do anything with them. All right. But notice what happens if I add a couple lines. So if I divide this 1/2 into 3 pieces, and I divide this 1/3 into 2 pieces, okay, and I'm going to draw a couple extra lines here. I have not changed the rectangles, but I did draw enough lines that we now have 6 equally sized pieces in each rectangle. Notice in the top rectangle, we have 1, 2, 3 of the pieces shaded in, and that is 3 out of 6 pieces. So this is equivalent, 1/2 is equivalent to 3 over 6. It's still half the rectangle, but now since the rectangle has 6 pieces, half of it is 3 of those pieces. Similarly, the bottom rectangle on the left has 6 pieces, but 2 of them are shaded. So 1/3 of a rectangle is equivalent to 2 out of 6 of that same size rectangle. But the rectangles on the right, despite being the same, give us those numbers in a way where we can actually work with them. So we have equally sized pieces now. So if I were to add these together, 3 out of 6 pieces and 2 out of 6 pieces, 3 out of 6 plus 2 out of 6 is going to be 5 out of 6 total pieces. So imagine if I took these two from the bottom here, if I took these and filled these ones in right here, so shade that one in and shade that one in, we would now have the original 3 out of 6 plus 2 out of 6, and we now have 1, 2, 3, 4, 5 out of the 6 pieces filled in. So 3 out of 6 plus 2 out of 6 gives me 5 out of 6. So now let's talk a little bit more about how we end up with that. So we're going to talk about comparing fractions real quick. To compare combined fractions, we need a common denominator, where we call it common because it's the same. Okay, when you hear the word common, you should think same. So in the previous example, we made both denominators 6. That way they had the same, or a common denominator. The lowest common denominator, LCD for short, is going to be the least common multiple, the LCM, of the two denominators we're given. Now, we might have more than two denominators in the future, but at least for right now, we're going to be working specifically with just two fractions at a time. Now, we've seen the least common multiple in the past. Remember, it was in the same lesson as greatest common factor, where the least common multiple is the smallest number that is divisible by both of the original numbers. So in the top here, we use 6 as our new denominator because 6 is the least common multiple of 2 and 3. Okay, so we just find the least common multiple of the denominators, and we call that the LCD for lowest common denominator. Once we find the lowest common denominator, rewrite each fraction as an equivalent fraction with that denominator. Okay, so just like before, we turned 1/2 into 3 out of 6 and 1/3 into 2 out of 6. So we just find an equivalent fraction with that new denominator. And then when we want to compare fractions with common denominators, all we have to do is look at the numerators. The fraction with the larger numerator is going to represent a larger value, and the fraction with a smaller numerator will represent the smaller value. So to compare fractions, we want to find a common denominator, rewrite both fractions with that common denominator, and then compare the numerators. This is also important because it's how we will add and subtract fractions on the next page. But right now, let's compare. So we want to rewrite 1/2 and 1/3 with a common denominator. So 1/2 and 1/3 are what we're starting with. If I want to find a common denominator, I need to know the least common multiple of 2 and 3. Okay, the least common multiple of 2 and 3 is 6. So we're going to turn both denominators into 6. In order to do that, 1/2, I'm going to multiply top and bottom both by 3 to get 3 out of 6. And 1/3, I'm going to multiply top and bottom both by 2 to get 2 out of 6. So now all I'm actually comparing is 3 out of 6 to 2 out of 6. All right, well, that's not too hard. We have the same denominator now, so we just have to pick the one with the bigger numerator. And 3 is bigger than 2. So I would say that 3 over 6 is bigger or greater than 2 out of 6. Where this symbol here just means greater than, if we turned it around, it would mean the other number is the bigger one. All right, but technically, we're not asking if 3 out of 6 is bigger than 2 out of 6. We're asking about 1/2. So once you have confirmed which one is which, then you just want to rewrite it in the original size. 1/2 is greater than 1/3. Okay, because we have a smaller fraction on the right side, we say that the left side is bigger. All right, number 2, we want to rewrite 3 out of 4 and 5 out of 6 with a common denominator and then compare. So 3 over 4 and 5 over 6, we need to figure out what is the least common multiple of 4 and 6. So if we were to do this the way we've done in the past using prime factorization, 4 is 2 times 2 and 6 is 2 times 3. So if we put together 2 times 2 and 2 times 3, we're going to end up with 2 times 2 times 3, which is 12. So the least common multiple of 4 and 6 is going to be 12. So I'm going to multiply top and bottom of the first fraction by 3 to get to 9 over 12, and top and bottom of the second fraction by 2 to get to 10 out of 12. And then now all I have to do is compare 9 out of 12 to 10 out of 12. 10 is bigger than 9, so we would say 9 out of 12 is less than 10 out of 12, which means that 3 over 4 is less than 5 over 6. Okay, 5 over 6 is bigger than 3 out of 4. All right, so now adding and subtracting when we have the same denominator is nice and simple. We're going to add and subtract the numerators and keep the denominator that they had in common. So you can see in the expression we have here, if we have a over d plus or minus b over d, notice the denominators are both d. That denominator stays the same, and then we just add or subtract what's on top. So a plus or minus b on top. So for number 1 down there, we have 3 over 8 plus 2 over 8. When we add these together, we add the numerators to get 5, and we leave that denominator the same. So just 5 over 8. Number 2, we have 5 over 9 minus 1 over 9. We're going to subtract the numerators to get 4, but we leave that denominator as 9. Whatever the common denominator was, it stays. Number 3, we have 7 over 10 plus 1 over 10. We add the numerators and keep that denominator. We end up with 8 over 10. And because we have already learned how to simplify fractions, we can go ahead and rewrite this. 8 and 10 have a GCF of 2, so we're going to go ahead and divide top and bottom by 2 to get 4 out of 5 is our reduced fraction. So that's going to be our answer. Let me just clean up my 4 there real quick. 4 over 5. There we go. So now that's the easy thing. But now what if they don't have the same denominator? Well, there's not really a cheat code for this. Okay. When they have different denominators, we're going to find equivalent fractions with a common denominator. And then we're just going to add or subtract like we did before. So essentially, we have to find the equivalent fractions first and then do what we did in numbers 1 through 3. So for number 4, we have 1 over 4 plus 1 over 8. We need to find a common denominator. The least common denominator, or the lowest common multiple of 4 and 8, is 8. So what I'm going to do is rewrite 1/4 as 2 over 8 by multiplying top and bottom by 2, and leave 1 over 8 alone because 8 is already the denominator we want. And then we're just going to add straight across. 2 over 8 plus 1 over 8 is 3 over 8. Number 5, we have 5 over 8 minus 1 over 3. This one's going to be a little bit harder because they don't have as convenient of a common denominator. The least common multiple of 8 and 3 is 24. So what we're going to have to do is turn 5 over 8 into 15 over 24, where all I did was multiply top and bottom by 3. And then we're going to turn 1/3 into 8 over 24, where all I did there was multiply top and bottom by 8. And then now we just subtract. So 15 minus 8 gives me 7 out of 24. All right, so the finding equivalent fractions part, remember, was the previous topic. So if you need a refresher on how to get from 5 over 8 to 15 over 24, go ahead and go back to lesson 7, watch that video. But we should be pretty comfortable now where we can multiply top and bottom by the same number real quick. All right, number 6, we have 2 over 5 plus 3 over 10. The least common multiple of 5 and 10 is 10. So I'm going to turn 2 over 5 into 4 over 10 by multiplying top and bottom by 2. And 3 over 10 will stay the same. 4 plus 3 is 7. So I end up with 7 over 10 as my final answer there. Okay, a couple applications here. Application number 1. You eat 1/4 of a pizza for lunch and 1/3 of the same pizza for dinner. What fraction of the pizza did you eat in total? So if you can imagine with me real quick, you ate 1/4 of this pizza for lunch. Then you come back and you decide to eat 1/3 of the pizza, which is roughly this much, for dinner. So we want to find out what in total did you eat. The word total is the key giveaway here that we need to add these fractions together. Okay, we're trying to figure out what is this piece plus this piece when we put these together. So now, visualizing wise, I can go ahead and draw an image that shows me that 1/4 is equivalent to 3 out of 12. So I can divide 1/4 into 3 pieces here, and those are each size 1/12. And then I can divide 1/3 into 4 pieces. 1, 2, 3, 4. And so by cutting it up like I did here, I actually made the entire pizza have 12 slices. And you can see that we have 7 of those 12 shaded in. So visualizing wise, I can actually do this without finding common denominators, but I promise you that doing it that way is going to be a lot more work for most situations. So instead, we want to actually work it out as 1/4 plus 1/3. Finding common denominators for each of these, we need a denominator of 12. So 1/4 becomes 3 over 12 by multiplying top and bottom by 3. 1/3 becomes 4 out of 12 by multiplying top and bottom by 4. And together, this gives me 7 out of 12. So in total, we ate 7/12 of the pizza. Now, number 8 is going to test us a bit. A tank is 3/4 full at the start of a drive. The drive uses 2/5 of the gas that was in the tank. What fraction of the full tank is left after the drive? So if you can imagine real quick, I'm going to draw a rectangle that's going to represent the amount of gas we have. And I'm going to divide it into 4 pieces because we start off with 3/4 of a full tank. All right, so we have 3/4 to start off with. It then says that the drive uses 2/5 of the gas that was in the tank. So out of the gas that's in the tank, we're using 2/5 of it. So if I were to divide this into 5 pieces, okay, 1, 2, 3, 4, we're going to use 2 of those 5 pieces. So these top 2 pieces here, 1, 2, 3, 4, 5, we're just going to cross off these top 2. All right, so what we actually have left is just these bottom 3 pieces here of the tank. So we're trying to figure out what fraction of the tank is this part down here that's left over. All right, well, we're going to have to do this in 2 steps. First, we need to find out how much gas we actually used. So it says that the drive uses 2/5 of the gas that was in the tank. So remember that the word of means to multiply. So we're going to do 2/5 multiplied by the amount of gas that was in the tank, which is 3/4 of the tank. Okay, when I work that out, I'm going to get 6 over 20, which is the same as 3 over 10 when I reduce it. Okay, just divided top and bottom by 2 there to get 3 out of 10. So the amount of gas we used is 3 out of 10. So this is amount used. All right, but now we want to find out how much gas is actually left in the tank. So we started with 3/4 of a tank, and then we used 3/10. So we have to subtract the amount we used from the amount we started with. So what we're actually working out here, okay, is the remaining gas is going to be 3/4 minus 3/10. I need to find common denominators now. So we're going to turn these into the lowest common denominator is 20 between 4 and 10. So 3/4 is going to become 15/20. And 3/10 is going to become 6/20. And then I just go ahead and subtract 15 minus 6 is going to give me 9 out of 20. So we have 9 out of 20, or just a little bit less than 1/2 of the gas tank remaining. So 9/20 of the tank remains. So we had to do multiplication of fractions and then do subtraction of fractions in order to get to that one. A little bit challenging there. All right, we're going to wrap up now with something that hopefully is not too bad. We're just going to talk about mixed numbers, which are something that all of us should be familiar with, but we've never necessarily worked with in great detail. So a mixed number is a whole number plus a fraction. So for example, 2 1/3 is the mixed number, but this really means 2 plus 1/3. We just don't write that addition symbol in the middle usually, because we use mixed numbers most often for everyday life things where we want it to be convenient. So for example, we might say that we need 1.5 cups of flour, but we don't say 1 plus 1/2 cups. We just say 1.5. We use that word and in there, but really that means addition. For calculations though, we do not like mixed numbers. Okay, for calculations, we change mixed numbers into what are called improper fractions. And these are fractions where the numerator is larger than the denominator. Okay, we prefer improper fractions because we actually know how to work with fractions, whereas working with mixed numbers is not convenient at all because you have both a whole number and a fraction part. We would rather just have a fraction. So now it's very easy to convert mixed numbers. So to turn a mixed number into an improper fraction, all we're going to have to do is multiply the whole number by the denominator of the fraction. And then we're going to add the numerator from the fraction to that result we got from multiplying and place that result over the original denominator. So if we look at the little equation we have here, we have a plus b over c is our mixed number. So a and b over c. What we're going to do is multiply a times c, so the whole number times the denominator, a times c there, and we're going to put that on top, and then we're going to add the original numerator. So we're going to multiply a times c and then add the original numerator, and then we just put all of that over c. So we keep that denominator the same. So watch how easy this is for number 9. We want to convert 3 2/5 to an improper fraction. So I'm just going to immediately convert this as 3 times 5 plus 2 over 5. So all I do is multiply the whole number times the denominator, 3 times 5, and then add the numerator to it. And all of that goes over the denominator. So 3 times 5 is 15, plus 2 is 17. So 3 2/5 is 17 over 5. For number 10, we have 5 1/4. So this is going to be 5 times 4 plus 1 all over 4. 5 times 4 is 20, plus 1 is 21 over 4. So 5 1/4 is actually just 21 over 4. All right, so now the reason we need to be able to do that is to be able to do some calculations. So let's look down at number 11 here. If you want to eat 5.5 donuts, but you stop yourself after 4 1/4 donuts, how many donuts short of what you wanted did you stop? So now this is a silly example. I like to eat a lot of donuts. That's just who I am. But oftentimes I end up stopping myself short of the number I actually want to eat. And so I'm proud of myself. But I need to know how proud of myself can I be. So I got to do the math to find out how far short did I stop. So we want to find out what is the difference between these two amounts of donuts. So what we're going to do first is turn them into improper fractions. 5 1/2 is going to be equivalent to 5 times 2 is 10 plus 1 is 11 over 2. Okay, just applying the formula from above. 4 1/4, 4 times 4 is 16 plus 1 is 17. So we get 17 over 4. So now we want to find out what is the difference or subtraction between 11 over 2 and 17 over 4. In order to work this out, we need to find a common denominator. So we're going to multiply 11 over 2 top and bottom by 2 to get the denominator to be 4. So we're going to have 22 over 4 minus the 17 over 4 that was already there gives us 5 over 4. And that is how many donuts short of what we wanted we stopped. All right, so now how do we turn 5 over 4 back into a mixed number if we want it to be one? Well, we just do long division and see what the remainder is. So if I divide 5 by 4, I'm going to get a quotient of 1 and a remainder of 1. So this is 1 1/4 donuts. Okay, so to turn it back into a mixed number, you just work out the long division. 5 divided by 4 gives you 1 with a remainder of 1. So it's 1 1/4. Number 12, a board is 5.5 feet long. You need to cut it into pieces that are each 1 3/4 feet long. How many pieces can you cut? So when you're trying to find out how many pieces of something you can cut, you're asking the question, how many of these 1 3/4 pieces fit into 5 1/2 feet of board? So first, the thing we're going to do is turn these into improper fractions. 5 1/2, we already saw earlier, is 11 over 2. And 1 3/4 is 1 times 4 is 4 plus 3 gives me 7 over 4. So now we're trying to figure out how many 7/4 fit into 11 over 2. So that means we're going to divide. We're going to do 11 over 2 divided by 7 over 4, where we can apply multiply by the reciprocal to get 11 over 2 multiplied by 4 over 7. This is going to work out to be 44 over 14. And because both of these numbers are divisible by 2, we can go ahead and reduce this fraction to be 22 over 7. So now if we want to turn that back into a mixed number, we divide and then we use the remainder to write the fraction. So 22 divided by 7 gives me 3 with a remainder of 1. So 3 1/7 is how many pieces we can cut. And if we're being realistic, you probably don't want 1/7 of a piece, right? So really we would round that down and say that we can cut 3 pieces. Because we can get 3 full pieces and then we would have 1/7 of a piece left over. All right, so now if you were questioning why I didn't write out all the steps of the long division, let me remind you that lesson 1 in Essential Skills taught us how to do long division. So if you're struggling to turn 5/4 into 1 1/4, all we did was do long division. 5 divided by 4 gives me 1 with a remainder of 1. And then I write that remainder over the denominator. Same thing down here, 22 over 7 gives me 3 with a remainder of 1. So it's 3 1/7. All right, that's all I got for you guys today. You made it through our 2 fraction topics. I'm proud of you, and I will see you on the next one.